Welcome to this edition of Math for No Reason. In this edition, we are going to discuss this very famous result which states that no prime of the form 4m plus 3 can be expressed as a sum of two squares of integers. Now, some examples of primes of the form 4m plus 3 are 3 for which m is equal to 0, 7 for which m is equal to 1, 11 for which m is equal to 2, and so on. So we see that quite a few of the small prime numbers are actually of the form 4m plus 3. Now, how do you prove this result? Now, note that if p is prime of the form 4m plus 3, if it is divided by 4, then the remainder is 3. So now if p is equal to a square plus b square, then we would expect that if a square plus b square is divided by 4, then it would also have a remainder 3. Now suppose we are working with a, and a can have these four forms. It can be of the form 4k, or it can be of the form 4k plus 1, or 4k plus 2, or 4k plus 3. So these are the only four possible forms of A, and similarly for B. B can also be any one of these. Now let us square A and see what we get. And a square can be any of these depending on which form you have for A. So if A is of the form 4k, then a square is 16k square, and when divided by 4, the remainder is 0. If a is of the form 4k plus 1, then a square is 16k square plus 8k plus 1, which when divided by 4 gives 1 as the remainder. If a is 4k plus 2, then a square is of the form 16k square plus 16k plus 4. Now again, when you divide this by 4, you get 0 as remainder. And for the form 4k plus 3, a square is of the form 16k square plus 24k plus 9, which when divided by 4 gives 1 as remainder. We see that a square when divided by 4 gives either 0 or 1 as remainder. Similarly for b square, thus we note that a square when divided by 4 gives either 0 or 1 as remainder, and similarly b square when divided by 4 would give either 0 or 1 as remainder. These are the two important facts that we will now use. Now if p is equal to a square plus b square, then what could be the possible remainders when a square plus b square is divided by 4? Since a square when divided by 4 has remainder either 0 or 1, and the same is true for b square, a square plus b square when divided by 4 can have remainders 0, 1 or 2. Note that 3 cannot be a remainder when a square plus b square is divided by 4. Thus, we cannot write p as a square plus b square, because p when divided by 4 has remainder 3, and that proves our assertion. This is a good place to stop. Thank you.